So let me tell you a little bit about the course Technologies and Processes at the Nanoscale. So what is nanotechnology? Well, nanotechnology is a device or a material which is below 100 nanometers in size. To put this into context, the width of a human hair is 100 microns in thickness. So we're talking about 100,000 times smaller than a human hair. In fact, the size drops down to that, very close to that of a virus or a molecule, and only just bigger than that of an atom. Why is this important? Well, everything around us is made up of atoms, and the properties of all of these products which are in front of us is based on the way we put these atoms together. Imagine our t-shirt. If we could redesign our t-shirt at the atomic level, perhaps we can change its properties. Perhaps we can make it bulletproof. Perhaps we can make it antibacterial. We would never have to wash it again. And it's this which is interesting about nanotechnology, that we can change the functionality of our devices. Because our devices are smaller, we also will use less materials, perhaps we have lower power requirements, and we can also access regions which are forbidden to larger products. This becomes very important, for example, if you are designing devices which will enter the human body. If we have smaller products, it also should mean that we use less natural resources. One of the most interesting things about the nanoscale is that the actual physical properties of our materials actually also change. One of the reasons that our physical properties change when we enter the nanoscale is that our surface area to volume ratio becomes extremely high. And this feature can change the actual physical properties of our materials with size. This is not the case if we had a non-nano-sized material. For example, if we take gold, we know that gold is a shiny metal, it's yellow, it's metallic, and this would be the same if we had 1 gram of it or if we had 100 grams of it. If we had the same gold and we go to the nanoscale, we can actually see that we have complete changes. We can change, for example, the color to being crimson to blue if we're in 30 to 500 nanometers in scale. If we drop down to that of 1 nanometer, we can see that we have an orange color. We also change from being metallic to non-metallic. So we're changing not only optical properties, but we're also changing the electrical properties as we are changing size within the nanoscale. This ability to change our physical properties at the nanoscale leads nanotechnologies to impact in many different devices. For example, they're found in fuel cells, they're found in carbon dioxide capture. Here in carbon dioxide capture, imagine our very large surface area to volume ratio is highly useful for offering a large surface area for carbon dioxide capture. We can find it in solar energy technologies. Again, here if we can alter our optical properties, it's very important, for example, in photovoltaics. It's also very important for renewable energy technologies that work in aggressive environments, for example in wind turbines, in geothermal energy, energy derived from the sea, which have very corrosive environments, which perhaps we can protect from by using coatings using nano technologies. If we can alter our electrical properties, we also find it in lots and lots of different electrical devices, including that of thermoelectrics, for example, in superconductors. We also find it in LEDs and lighting, again because if we are altering our optical properties, this is now focusing and managing to tailor our properties for these technologies. We also find it in batteries. So we already start to see these nanomaterials in our everyday life. We can see them in computers, we can see them in medical diagnostic equipment, pharmaceutical products, in our vehicles, in catalytic converters, and also in corrosion treatments, fabrics that can have higher stain resistance, etc., water filters. We can see them in sports clothing with sports clothing with stronger and lighter weights. We can have sunscreens made from nanoparticles which protect us from the sun, in drink bottles to stop oxidation of the drink itself inside, chemical sensors, etc. And what we can see is that the growth of nanotechnologies has really exploded in the last decade. It's very important, obviously, because this is the type of device and the type of materials that engineers of the future will be using. So nanotechnology, and to learn about nanotechnology, is highly important and timely. So let's just talk about the course itself. The course itself is led by 3 people, Duncan, Fagg, Paolo Marquez and Victor Neto. And we also have guest lectures coming who all work in the University of Aveiro in nanotechnologies, who will be taking you, well, firstly giving you lectures and also then taking you to the laboratories to show you what they actually do in research in nanotechnologies in the University of Aveiro. So the course itself will give you an introduction to nanotechnology, an introduction to the nanoscale and nanomaterials. It will also give you information about the nanoscale products and applications. Then we will move on to have these guest lectures on nanomaterials preparation and characterization, which you can see here, many different types of techniques of characterization of nanomaterials and also ways of making nanomaterials. Nanomaterials in hydrogen storage and in plastics and nanocomposites, etc. We'll also give you a little bit on nanosafety, because obviously if we're changing the properties of our materials, giving ourselves new properties, we have to make sure that these properties are actually safe and that we are not going to make ourselves ill by the use of nanomaterials. We also need to talk about nanotechnology, nanotoxicology, and especially with actually seeing the life cycle of nanomaterials. Okay, maybe we're using less raw materials because we are working at the nanoscale. Nonetheless, can we actually recycle our materials when they're at the nanoscale? So what will you actually be doing in this course? Well, in this course you'll be working in pairs and you'll be doing a mini review on nanotechnology, and this can be any nanotechnology you fancy in the field of mechanical engineering. And what we want is we want to know why it's important, what benefits does it give over bulk options for this technology, what are the safety issues, what are the economic factors, what characterization techniques are required, and a life cycle analysis, and also what are the alternatives. This will be presented in an article format and also in your pairs orally during this course. Okay, thank you very much.